This question says, for what values of x is this series convergent? And we're supposed to write our answer in set builder notation. Okay, so in the last questions, right, we just had numbers. We didn't have actual, like, the variable x going on in every one of these. But that's what we're trying to find out. We want to say, okay, what values of x would actually make this series actually converge on a single number when you added them all together, right? So in the last questions, we kept on saying this, that the absolute value of r has to be less than 1. Okay? So what this is going to require is if we can figure out what r is, then that'd be a good starting point. But in this case, we're just going to be able to find an expression for what r is. But if you remember from before, what we did is we took the second term and we divided by the first term, and that would tell us what the common ratio was. So let's do that here. So we'll say r is equal to, and it's 1 over 4 x plus 1, and then divided by 3 over 4. And now, right off the bat, to make this nicer, why don't we use our rule that dividing by a fraction is the same as multiplying by the reciprocal. So I'm going to say this is the same thing as just saying 1 over 4 x plus 1 times, and then flip that upside down, right? So 4 over 3. And it's already looking nicer, and then we can simplify it up a bit more by saying the 4's cancel. So now we have r is equal to, and I'm going to write it as 1 over 3 x plus 1. Yeah, much better. Okay, so if the absolute value of r has to be greater than 1 for this thing to actually be convergent, then I can say 1 over 3 x plus 1, like the absolute value of that has to be less than 1, right? Because this is r. All right, so now we just need to figure out what are the values of x that would make this statement true. And if you can think back to your absolute value lessons, most likely in Math 20-1, there's actually going to be two scenarios when this is true, right? Like when we have the absolute value just like makes it positive. So there's two scenarios for this, right? There's the positive version, right? But there's also like the negative version. So let's actually just look at both scenarios. So we'll say, okay, where is, and I'll do it over here. Where is positive? Like the positive case would be like positive 1 over 3 x plus 1. Where is this less than 1? Now we can just kind of solve this, right? So let's, well, there's different ways to do this. I think what the easiest way here would actually just be to multiply both sides of this equation or inequality by 3. So I'm going to multiply this by 3 and this by 3. Okay, so that made those cancel. That's why I'm doing it, right? I just want to get rid of that 3 in the denominator. And then I have 3 on this side. So now what we have left is x plus 1 must be less than 3. Okay, so now we'll just subtract 2 from both sides, or subtract 1 from both sides. Minus 1, minus 1. So we end up with x has to be less than 2. All right, so that's like one part of our equation, or our inequality here. And now let's do the other one. So now the other part of this you can think of as like the negative version, right? Because if you had negative 1 over 3 x plus 1 and then took the absolute value, right, then you're taking the positive version. So now let's say, okay, what would it be if it was negative 1 over 3 times x plus 1? And that has to be less than 1. Okay, so let's do the same thing, but this time what I'm going to do is I'm actually going to multiply, well, by 3 again, but I'm going to multiply by negative 3, right? And that's just going to get rid of the negative. I don't need to. I can do that in the next step too, but if I multiply by negative 3, right, then those negatives will cancel. So then I can multiply by negative 3 on this side as well. So hopefully that made sense. So now let's say, okay, we've got x plus 1. Now, if hopefully you've seen this, sometimes this doesn't get taught that well in 20-1, but if you ever multiply or divide with an inequality, the sign actually changes direction. So since we multiply by -3 on both sides, we got to switch the sign. Okay, so now it's greater than -3. All right, so now we will subtract 1 from both sides, so -1. So now we get x has to be greater than -4. So now if we just combine these two solutions, then we can say, well, in general, x has to be greater than -4, and x has to be less than 2. And then you'd say where x is an element or a member of the real numbers. All right, so that's what would go here, right? And then you get x. Yeah. Okay, now find the sum of the series for those values of x. All right, so just like in the last ones, now that we know, within these values of x, our series is going to be convergent, well, now we can actually just kind of throw it into our equation. So we can say, well, the equation for an infinite series was a over 1 minus r. And we have an expression for r, right? But what's our a value? Well, that's actually pretty straightforward. Our a value is written there, right? It's 3 over 4. That's just our first value. So let's fill this in. So this is going to be 3 over 4 over, and then 1 minus, and then our r value is 1 over 3 x plus 1. All right, so now let's simplify this up a bit. So what I'm going to do is I'm going to actually expand the 1 over 3 into this one on the next row down. So now we've got 3 over 4 over 1 minus x over 3 minus 1 over 3. Okay, so keeping on going. I'm just going to simplify up the 1 and then minus 1 over 3 in the next row here. So 3 over 4 over. And then you can think of this 1 as being 3 over 3, right? So 3 over 3 minus 1 over 3. This becomes 2 over 3 minus our still have x over 3. Okay, so now on the next row, we've got 3 over 4 over, and now we have a common denominator already, right? So we've got over 3. Why don't we go ahead and just write this all over 3? So we can say this is 2 minus x all over that common denominator of 3. All right, I promise it will start looking better. So now we've got our fraction on the top, our fraction on the bottom. Let's make this look a little nicer. I'm just going to carry on up here by using the fact that dividing by a fraction is the same as multiplying by the reciprocal. So we'll say 3 over 4 and change this to times 3 over 2 minus x. Yeah. Okay, so then we'll simplify this guy up. So this is the same now as 9. So 3 times 3 is 9. And then this was really like it's in brackets, right? So we have to distribute the 4 into this. So this becomes 8 minus 4x. And there you go. That would be the sum at infinity. So it would depend on the value of x, right? But this is like an actual equation that would tell you the sum at infinity for that expression.